All right, now we're going to look at side, angle, side. Triangles can be proven to be congruent when two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle. So I want to clarify, the included angle is formed by the congruent sides. So looking at the triangle that I have marked here, AC is congruent to ED, AB is congruent to EF, and the included angle is the angle formed by these two congruent sides, so that would be angle A and angle E. If this is true, two sides and the included angle of one triangle are congruent to two sides and an included angle on another triangle, the triangles are congruent. And again, I use this coloring to make sure that my congruency statement is correct. Triangle ABC is congruent to triangle EFD by side, angle, side. So let's walk through a proof that is completely filled out and how we can mark our diagrams. We are given C is the midpoint of segment AD. A midpoint separates a line segment into two congruent segments. C is the midpoint of segment BE, so that means it too separates BE into two congruent segments. So we have our two sides that are congruent. Notice that angle BCA and angle ECD form vertical angles. Since they form vertical angles, then we know that they are congruent. So as I've marked, C is the midpoint of AD, therefore AC is congruent to DC. And because C is the midpoint of BE, that means that BC is congruent to EC. Now, notice that they are listed as a statement. They are not listed in the given because the only thing we're given, C is the midpoint of AD and is the midpoint of BE. But now we know these two pairs of segments are congruent because of the definition of midpoint. We also have a pair of vertical angles, and we know that all vertical angles are congruent. Therefore, notice what we have. Side, angle, side. And we want to make sure that we have them lined up. So ABC is congruent to triangle ABC is congruent to triangle DEC by side, angle, side. So again, side, angle, side is what we're working with. So let's look at example 2. Now we have the statements, but we need to supply the reasons. Here we have GH is parallel to FJ. Anytime you have parallel sides, look for congruent angles. And when you have parallel lines cut by a transversal, your choices in this situation would be alternate interior, alternate exterior, or corresponding angles. Okay, so just keep that in the back of your mind. You're told that GH is congruent to FJ, and that is marked in your diagram. Okay, so I'm going to go ahead and highlight those. Okay, so this is what we were given, taken straight up from above the proof. Okay. Notice both triangles have a shared side. Anytime you have a shared side or a shared angle, you're probably going to use reflexive property. So this would be reflexive property. All right. So we've got our two sides. Let's check and see if angle HGJ could potentially be congruent to angle FJG. Okay? So remember, we have parallel lines cut by a transversal. Notice that these two angles are in fact alternate interior angles. So we can state that they are congruent because of the alternate interior angle theorem. I'm going to mark those. So now look what we have. Side angle side, side angle side. So they are congruent by side angle side. All right. Example 3. We don't have any statements, any reasons. All we have is a marked figure. Okay. Notice that these two sides have the same tick mark. So by the diagram, that means AD is congruent to CB. And we also have arcs here, which means that this angle BDA is congruent to angle DBC. Notice I can't just say angle D or angle B because there's two angles here that have D as a vertex and two angles here that have B as a vertex. So I can't just say angle D and angle B. So I'm going to go ahead and write down my given. AD is congruent to CB. Angle BDA is congruent to angle DBC. And this is given. So we want to prove that two sides are congruent. Again, if we're trying to prove sides or angles are congruent, we need to get to CPCTC. And before that, we need to prove that the triangles are congruent. So as I look at the diagram, I notice that there is a shared side. That means that segment BD is congruent to segment BD by reflexive property. So notice I have side angle side. So triangle ADB is going to be congruent to triangle CBD. Triangle ADB is congruent to triangle CBD. And that's going to be side angle side. And since this triangle is congruent to this triangle, and this is written properly, notice that side AB is congruent to side CD. And again, corresponding parts of congruent triangles are congruent.